Now that we have finished simulating the blazer in the 3D window, it is time to apply materials. We will be running through the whole process of applying the materials as specified in the specification sheet. We will also be refining the simulation of the jacket as we go. We highly recommend that you try materializing and refining the jacket first with the knowledge that you have. Then use this video to verify and review. If you would like to try it out first, you can pause the video here. We start off with applying the right fabrics to the garment. For the shell and facing patterns, we are using a wool lightweight material, which we can download from the Browseware Cloud library. We search for the wool lightweight fabric and check that it is the correct composition of 100% wool and that it is 292 grams per meter square mass. The fabric should have an all-over print as the diffuse map. In the materials folder we have downloaded, the print JPEG is available. So we replace the existing diffuse map of the wool lightweight with the all-over print. The diffuse color needs to be reset, as we want the true color of the print. The spec sheet states that the scale of the print should be 200%. We click the diffuse map in the context view and change the size to 200% in the image editor. Before we assign, we need to remember that there are patterns for this blazer that would have been constructed with 2 layers instead of 1. For example, the collar and pocket patterns. Therefore, we need to create a clone of the fabric and edit the physics to be doubled. Once we have cloned, we can rename the new fabric and add DBL at the front to indicate that this is a double layer fabric. We click on Physics and adjust the values. The mass, thickness, stretch, and shear values need to be doubled. And the bend values need to be multiplied by 10. Now we apply the double fabric to the patterns that require it: the collar, collar stand, pocket flap, and welt patterns. Then we assign the original fabric to the other shell patterns and facing. Next, we need to download the fabric for the lining. In the Cloud library, we search for a lining fabric that is 100% polyester and has a mass of 74 grams per meter square. Once this is downloaded, we can assign the fabric to all lining patterns. The color of the lining patterns needs to be adjusted. We input the RGB code stated on the spec sheet. The values are 150, 93, and 57. The color blending mode needs to be adjusted to recolor. And we also need to ensure that the back of the fabric has the same changes made. Now we dress the garment to allow it to simulate with the new fabric physics. On the chest pocket, we have not added the pocket square. We need to create a pattern for this. Since this is a faux pocket, we do not have to create the full pocket square. Instead, we create a rectangle, fold it into 2, and stitch it to the opening of the chest pocket. We select the internal lines on the chest to check the measurements we require for the pocket square pattern. Then we insert a rectangle. We insert one that is 9.9 centimeters in width and 1.4 centimeters in height. We select the bottom or top edge of the pocket square and create a clone by offset of negative 0.7 centimeters. This is the fold line. Next, we enable the fold property of this pattern. We add the pocket square pattern into the front torso and adjust its position in prepare mode. We stitch the pocket square to itself. Then stitch the bottom edge of the pocket square to the chest pocket opening. We also must adjust the stitch length. To secure the pocket square, we stitch the fold line to the internal line on the bodice pattern, like this. We must adjust the 3D layer. The 3D layer needs to be higher than the bodice, but lower than the welt. We adjust the pocket square to be on layer 9, and the welt pattern to be increased to layer 10. Great! Now for the fabric, we need a silk material. In the library, we search for a silk, GGT, checking it has a composition of 100% silk and a mass of 24 grams per meter square. We download the material. Then we assign it to the pocket square pattern. And we adjust the color of the diffuse map to be white. Now we can dress the garment. Our next step is to apply the seams. There are only single top stitches that need to be added to the collar and the chest welt pocket. In the Seams Resources, we click on the drop-down to add a single needle stitch. We select the single needle stitch and adjust the workmanship to match the specs. The offset is 0.15 centimeters. Thickness, 0.06 centimeters. Space, 0.05 centimeters, and 15 stitches per inch. The color also needs to be adjusted. We input the RGB code stated on the spec sheet, 90, 96, and 133. Then we apply the seam to the required edges. Next, we have trims. We have already assigned the buttons for the front bodice and sleeves. We need to add a button to the triangular flap on the inside of the jacket. We assign the smaller button to the flap and to the facing pattern. We rotate the buttonhole so that it's vertical. Then we click on the Smart button assigned and move the button to inside. We use the focus navigation to view if the button was correctly added when we dress the garment. We need to check that the layers are correct. The flap should be simulating below the top welt patterns. So we need to adjust the flap to be layer 1 and the top welt to be layer 0. Then, using the pinch focused effect, we pinch the pattern so that they are sitting correctly. Done! Next, we want to assign the label on the collar stand. The label can be found in the Materials folder we downloaded. We add the image as a piece assignable trim. Next, we assign the label to the collar stand. We need to adjust the size as required in the spec sheet. We adjust the position of the label in the 2D window and ensure that it snaps to the center of the pattern. Then, we adjust the Y position to 0.3 centimeters. In the 3D window, the label is not showing. This is because the label needs to be visible on the inside of the pattern. We enable Inside and disable Outside. The edges of the label need to be stitched down. We do so by using the pen tool and drawing a line along the side of the label. Then we assign the single stitch to the internal lines. The last trim we need to assign is the piping detail. There are two ways to create piping details. One is by using an edge assignable trim, and the other way is to create the piping patterns and stitch to the edges of the patterns. You can decide if it would be necessary to achieve the piping detail with patterns, depending on what you're trying to achieve with the garment. If we add patterns, we need to take into consideration that there will be another layer of patterns that can affect the simulation of the garment. Thus, if you are only looking to have a more visual effect, or if you want to make it easier to simulate the layers, you can just use an edge assignable trim method. For this garment, we use an edge assignable trim. the edge assignable trim is in the material folder. We add the piping as an edge assignable trim. Then we assign the piping to the edges of the lining. We need to adjust the piping width to 0.5 centimeters. We do so by adjusting the height of the trim in the image editor. To improve the look of the piping, we also enable auto-generate depth maps. The final step is to refine the jacket. This includes ensuring that the styling is as intended, adjusting the grid size, and ensuring the materials and stitch construction used are suitable for rendering. In the 3D window, if there are any internal lines shown, we clear the Visible in 3D property for those lines. Next, we adjust the stitch construction of the edges and internal lines. We can use the V-Ray preview window to check the effect of the stitch construction. If using a directional seam type, we must also adjust the direction of the stitch construction. For example, the collar stand stitch construction depth looks too high. And we also need to adjust it to a directional seam, as the seam allowance would have been tucked to the collar stand. After adjusting, we check the V-Ray preview window again. This looks much better. We continue to check the entire jacket and adjust as needed. Next, we want to adjust the grid size for the patterns. For larger patterns, we can adjust the grid to 0.6. For the smaller patterns, we can adjust the grid size to be much smaller. For instance, the pocket patterns, the pocket square, the collar, and the collar stand. We can use values between 0.3 to 0.5. This allows the folds of the jacket patterns and the smaller patterns to have a more realistic drape. Once we have adjusted the grid, we allow the garment to simulate to accommodate the change of the grid sizes. We can also apply force multiplier to areas that require more reinforcement. For example, the edges of the collar, the lapel facing, pocket flaps, and the hem facing. Remember that the amount of force multiplier we add would depend on the number of layers that are stitched onto that edge. The depth would be the depth of the seam allowance. A tip for the hem facing. We can add a small amount of force multiplier between 1.2 and 1.5 with a depth of the height of the grown facing. This can help to stiffen the hem so that it's smoother. We use the styling tool to pinch out areas that are not sitting nicely. We can use the hold function on areas like the collar to ensure it stays in place. We can use the V-Ray preview to check if there are any collisions. And we have completed the jacket. You can try and create a ray trace render output. Apply what you have learned in the rendering lesson. Remember, it's good practice to clean up the file by deleting unused materials and screenshots. For more information, visit our help website.